Hey guys, Mrs. Stans here. So just a quick review of solving equations. We did this in Unit 1 back in September. So this should go pretty quick, and then you'll feel more confident doing your homework page. So number 1 is a two-step equation. We're going to be using our properties of equality. Remember, the equal sign is like the center of the equation. Is where the equation is balanced. Whatever you do to one side, you do to the other. So I will use the subtraction property of equality and subtract 7 from both sides. So I have 3x equals 6. Divide both sides by 3. This is the division property of equality, and x equals 2. I just want to review how to do a check. When you do a check, you use the original equation, you substitute in the value that you found for x, and then you follow the order of operations on each side of the equation. So over here I'll do 6 plus 7, and then I'll do 6 plus, I'll do 2 times 3 to get 6, and then 6 plus 7 to get 13. On the right side, there isn't anything to do, so I just bring down the 13. When you have the same value on each side of the equal sign, you should be certain that the value of x that you found is correct. Example 2, when there's variables on both sides, my first step that I always do is to get the variables to one side. I feel like subtracting 9a from both sides. Notice how I said I feel like. I could have subtracted 14a from both sides. I actually could have done something with the constants of 5 or negative 5 actually, but I do deal with my variables first. So on the left side I have 5 plus 5a equals, don't forget this minus sign in front of the 5 actually tells us that that's a negative 5. Now that my variables are on one side, I have to get my constants to the other. So now I will subtract the 5 from the left side. Whatever I do to one side, I have to do to the other. A positive 5 and a negative 5 is 0, so it's gone. I have a 5a on the left side. But a negative 5 and a negative 5 is a negative 10. Finally, I want just 1a, so I will divide both sides by 5 to get 1a, and a equals negative 2. Again, if I were to do a check, I would use the original equation. I would substitute in a negative 2 for a. Whenever you substitute, you really should put it in parentheses. And then I use the order of operations on each side of the equal sign. So I do one side at a time. I have to multiply before I add. So I have a negative 28. I have 5 plus a negative 28, which turns out to be negative 23. On the right side, I have negative 18 minus 5, which turns out to be negative 23. So I'm happy that both sides are the same because I must have solved correctly. Example 3. Now we have to distribute and combine like terms. Remember, this is like the center of the equation. So I can distribute over here to get 14e minus 7 minus 11. I'll bring down what's on the right side of the equation. I also see that there are 3 things on the left side of the equation. Whenever you have more than 2 things, there must be something that can combine. The negative 7 and the negative 11 can combine. I have 14e minus 18 equals 6 plus 6e. Now this equation is now at the same stage that example 2 was on. And I had told you before I like to take care of my variables first. So I will take care of these e's. I feel like subtracting 6e from both sides. Again, I could have subtracted 14e if I wanted to, but I feel like subtracting 6e. So I have 8e minus 18 equals 6. Now I will add 18 to both sides. That really is my only next best step. So 8e equals 24. Finally, divide both sides by 8. E equals 3. Again, you can do a check. Checks are on your final exam, by the way. So even though these don't say to check, we should practice our checks. I have to do what's inside these parentheses first. So I have a 6 minus 1. Remember, we're following the order of operations. The order of operations really doesn't include the distributive property. When it says parentheses, they're talking about do what's inside. I want you to really get in the habit of only using the distributive property when variables are involved. If it's all numerical, please do what's inside the parentheses. So this is a 5. Just want to separate this so it doesn't blend in. 7 times 5 is 35 minus 11 is 24. Now I'm going to see what's on the right side of my equation. I have to multiply first, so I have 6 plus 18, and then I have to combine, and I get 24. I can bring that down, and I'm happy they're the same. Next page. So here's a hint for you that our value of x is going to turn out to be a fraction. Some people think that that means they did something wrong. And no, you don't do anything wrong. It's okay to have a fraction. If I add 6 to both sides, I get 25. So when I divide both sides by 2, you are allowed to leave your answer as 25 over 2. There isn't anything wrong with that answer. It's actually a pretty nice answer when you're doing a check. If I changed this to a mixed number, I would just have to change it back to improper in order to do the check. When we do a check, I can see that I'm going to have to multiply. And when we multiply with fractions, we actually like improper fractions, not mixed numbers. This is like a 2 over 1, and I can simplify here. So I get 25 over 1, but I don't need a 1 in the denominator. And 25 minus 6 is 19. So both sides of the equation are the same. And then if you have a fractional coefficient, first let's add the 1 to both sides. I like multiplying both sides by the reciprocal. If I multiply by 5 over 2, the 5's simplify to be 1, and the 2's simplify to be 1. Don't forget, whatever you do to one side, you have to do to the other. So on the left side, I'm left with just 1x. On the right side, I could put a 1 underneath this and simplify again, and I'm left with 50. So notice, not so bad. I'm not going to do a check for this one. I want to save this room for something that I see is omitted from this worksheet. You know how sometimes we get no solution or infinite number of solutions, so I just want to review that. A no solution would be an equation that maybe looks like this. 2x plus 5 equals 2x minus 3. As soon as I see that the coefficients of the variables are the same on each side, I know that there is something interesting that's going to happen. The only time there's a solution is when the coefficients of the variables are different on each side. Let's just go look back at all the problems that we did that have a solution. The coefficient of x over here is 3, and there isn't an x on the right side, which means that the coefficients of the variables must be different. On example 2, the coefficient to the a is 14 on one side and 9 on the other. Therefore, there is one solution. On example 3, you do want to simplify and combine first before you decide if there's a solution or not. So we want to look at this step right here. The coefficients on each side are different. One of them has a 14, the other one has a 6. On example 4, the coefficients are different on each side because on the left side the coefficient of x is a 2. On the right side there isn't even an x, which means coefficient is a 0. And same thing on number 5. The coefficients are different because the coefficient on the left side is 2/5. The coefficient on the right side, there isn't one. So the reason why this problem that I created has no solution is because since the coefficients are the same on each side, but the constants are different, it's impossible to solve this. And if you don't see that just yet, let's try and solve this. Remember, I like to take care of the variables first. So how about I subtract 2x from both sides? And right there, I'm already having a problem because 2x minus 2x, this is gone. All I'm left with is a 5 on the left side. And then 2x minus 2x, this is gone. All I'm left with is a -3 on the right side. And then you should be putting question marks here. Really? Does 5 equal -3? No, it doesn't. Are they telling me what the value of x is? They're not. So this just has no solution. This is nonsense what I'm left with, so there's no solution. An equation has an infinite number of solutions. Would be something like 2x plus 10 equals 2x plus 10. So again, that interesting thing has happened where the coefficients are the same on each side. But even more interestingly is that the constants are the same on each side. If an equation is identical on each side of the equal sign, you're guaranteed to have an infinite number of solutions. If for some reason you don't notice right away and you decide to start solving by subtracting 2x from both sides, again, 2x minus 2x gone, but I'm left with a 10 on the left side, and then 2x minus 2x gone, and I'm left with a 10 on the right side. At least this is a true statement. They're telling us that it's true always, no matter what x is. That's why there's an infinite number of solutions. An infinite number of solutions really means that any value of x will check. Any value of x will check. I could plug in a 1 on each side, and I would get 12 equals 12. I could plug in a 0 on each side. I'd get 10 equals 10. Any value I plug in for x, the check will always work. On the one with no solution, there is no value of x that I could substitute in that makes it true. Nothing will work. Nothing. So there's your notes for a review of solving equations, and now you can do your worksheet, and I will send out the answers to that worksheet within the next couple of days. If you have questions, please send them to me through Remind. I've been checking my email also, and we do have a video chat today, Wednesday the 18th at 11:30. So, see you soon.